welcome to semester exam chapter 4. The end is in sight. One of the first topics that we discussed in chapter 4 dealt with midpoints, and I'm going to throw slopes and midpoints together just because both deal with ordered pairs, and there's sometimes confusion with midpoints and slopes just because of what their formulas look like. Now the midpoint formula, if you remember right, is x sub 2 plus x sub 1, or vice versa, divided by 2, comma, y sub 2 plus y sub 1, divided by 2. Now if you look in your book, you're going to see the x sub 2, x sub 1 reversed. It really doesn't matter. The point of me doing that was to show you it doesn't matter which x-coordinate you take first. You're going to add both x-coordinates together, divide by 2 to get your midpoint. So when I'm given a question that says, find the midpoint and slope, which we will in a minute. So find the midpoint of a line segment with points negative 2, 4, and 6, 8. We are simply going to take negative 2, add 6, those would be our x-coordinates, and divide by 2 to get negative 2 plus 6, 4, 4 divided by 2, which is 2, comma, 4 plus 8 divided by 2. Why? Because our y-coordinates in this particular case happen to be 4 and 8, so we're going to add those together. 4 plus 8 is 12 divided by 2, and we get 6. Our midpoint is 2, 6. It's an ordered pair. So 2, 1, 2, 3, 4, 5, 6. That point is the midpoint of negative 2, 4, which is here, and 6, 8, which is here, if we were to graph that. Now, slope works a little bit differently, obviously. Slope, rise over run. We've mentioned several other ways to describe slope. But to find the slope of this line, we want to know how much, again, does our line rise in comparison to how much it runs. Okay? So to find slope, I'm going to write this down here. We have a formula y2 minus y1 over x2 minus x1. It's the change in y divided by the change in x. And of course, one of the most common mistakes is people will take the change in x divided by the change in y. Incorrect. So looking at the same problem from above, I want to know what the slope of the blue line I have above is with the points negative 2, 4 and 6, 8. And it's a simple process, fellas. We're going to take the second y-coordinate, which is 8, and we're going to subtract the first y-coordinate, which is 4, and divide that by the second x-coordinate, which is 6, minus a negative 2. Again, a second huge mistake I see when people are dealing with slope is the confusion of signs. A negative, or a positive minus a negative, whatever you want to call it. I see sign issues. In this particular problem, the numerator 8 minus 4 is 4. The denominator is 6 minus a negative 2. We're basically adding 6 and 2 to get 8. And of course, we reduce at the end. Our slope is going to be 1/2. So going back to my diagram above, for every 1 unit I rise, I'm running 2 units. Rise 1, run 2, etc. That's what slope is. Now, I want you to find the midpoint and the slope of the line segment below. Go ahead and hit pause and do that on a sheet of loose leaf. Now, once we covered the basics of slope, we got into some more complicated problems. We talked about parallel lines, and we also talked about perpendicular lines. Parallel lines, remember, have slopes that are the same. Perpendicular lines have slopes that are opposite reciprocals. So, for instance, if I have a slope of, let's say, 3/4 for one line, its perpendicular would have a slope of negative 4/3. Opposite meaning positive to negative, reciprocal meaning we take the 3/4 and flip-flop numerator and denominator to get 4/3. Okay, so that's a key point we're going to have to remember for problem number 2 here. Now, looking at problem number 1, you can see I've given you two lines. And in the given information, it says the lines above are parallel. Solve for y. So the first thing you should be thinking about is the fact that both of those lines are going to have the same slope. Now, the line on the left, it's going to be pretty easy to find the slope. We're just going to take 18 minus 10 and divide that by 12 minus 6, which gives us 8 over 6, which reduces to 4/3. Now that's key because we know our bottom line is also going to have a slope of 4/3. Again, the lines are parallel. In order to find y, we are going to use our slope formula again. So we're going to say the difference in the y values, in other words, y minus 8 divided by 14 minus 10, that is going to give us 4/3 because we have already established the slope of this second line is the same as the slope of the line on the left. They're both a slope of 4/3. So at this particular juncture, we're simply going to cross multiply. Now, to make it a little bit easier for us, we can change this equation into y minus 8 over 4 equals 4/3 to make things a little bit easier for us. Now, I'll tell you a major mistake here. When people cross multiply, 4 times 4 is of course 16, but when they cross multiply the y minus 8 times 3, oftentimes they forget to distribute. It's really going to be 3 times the quantity, y minus 8. So that'll give us 16 equals 3y minus 24. When I add 24 to both sides, I get 3y equals 40. Divide by 3, and our y value is 40/3. Kind of a strange answer. It can't be simplified, but it is the correct answer. Y is in fact equal to 40/3. Now, let's move on to the problem on the right. The problem on the right is a problem I gave you on the Chapter 4 test, and a lot of people miss this one because they didn't put everything together as far as logic goes. All I'm asking you to do is solve for w. Similar to the problem on the left, but a little bit different. The one thing that we do know for a fact is that we can find the slope of the line I am coloring in gray. I can take -3 minus a -10 and divide that by -5 minus 0, and my slope is going to be -3 minus a -10 is basically -3 plus 10, so that's going to be 7 over -5. That is the slope of my gray line. Now, here's where people got lost and did not know what to do. But this little box here, this 90-degree angle, is the key. That shows perpendicularity. I know for a fact that the slope of this green line is going to be the opposite reciprocal of -7/5. So it's going to be a positive 5/7. Again, we go from negative slope to positive slope. We have the reciprocal of 7/5, which is 5/7. So at this point, I can set up an equation using the two ordered pairs 10, w and 0, -10 to solve for w. Simply going to say w minus -10 divided by 10 minus 0 equals our slope of 5/7. So we get w plus 10 over 10 equals 5/7, and you are going to simply cross multiply and solve, and remember you are going to distribute the 7 to both the w and the positive 10. So go ahead on your piece of loose leaf, finish out that problem, and tell me what does w equal. Okay, this next problem again was a problem I gave you right on the test for Chapter 4. I've probably asked you this in homework and quizzes and tests probably 2, 3, 4 times already, but it's a good question that covers a lot of information from Chapter 4. First part says find the midpoints x, y, and z. We'll take a look at one and let you do the other two on loose leaf. X, again, don't confuse slope with midpoint. X is going to be found by taking 15 and adding it to 12, dividing it by 2, comma, 10 plus 4 divided by 2. And that ordered pair is going to be 27 halves. You can change that to 13.5 if you want, comma, 10 plus 4 is 14 over 2 is 7. All right, there's your x value. I should say midpoint for point x. Now, on your piece of loose leaf, I want you to give the midpoint for y and z. Do that one on your own. Also, I want the slope of all three sides of the triangle. We'll do one together, and you can do the other two on your own. So we're going to find the slope of line BC. All right? And that's simply, again, going to equal y minus y divided by x minus x. 10 minus 4 divided by 15 minus 12. And that's going to give us 6 over 3. So the slope is simply reduced to 2. No reason to write the denominator of 1. So I want you on your own to find the slope of line segment AC and line segment AB. That should be no problem. You can do that on your own. Next up, part C. Find the slope of the medians from points A, B, and C. Okay, so we have to review what we know about medians. Hopefully you remember, a median is a line segment that starts from a point. I'm going to do point A to start. And the median goes to the opposite side of the triangle, and it breaks that opposite side into two congruent parts. In other words, it goes to the midpoint of the other side. Now, this problem I can already see is going to be fairly messy because I have a midpoint x that is at 13.5, comma 7. It's going to be a little bit messy to deal with because I'm dealing with a fraction. So, to find the median, I'm simply going to take that x value, which is 13.5, comma 7, and the a value, which is negative 3, comma 7, and I am going to figure out what the slope is. So, I'm going to take 7, let me change colors here, 7 minus 7, and divide that by 13.5 minus a negative 3. And I lucked out a little bit here because I end up with a slope of 0 over 16.5. And irregardless of what the denominator is, I know that my slope is going to be 0. So the slope of that line is 0. Now, it doesn't really look like it from my diagram because I don't have a perfectly drawn diagram, but that is the case. The slope is 0. Now, I want you to find the slope of the median from point B and from point C. So from point B, you're going to go obviously to point Y. So in order to do that problem, you have to find Y's midpoint, which you should have already done for part A. You're going to have some organization in this problem. Part D, find the slope of the altitude from points A, B, and C. Now, remember what an altitude is. An altitude is obviously different than a median. By definition, an altitude starts at the point A, and it will go to the opposite side, but as it goes to the opposite side, I'll make a dotted line here, we actually form a right angle. We have perpendicularity. So this problem is actually a little bit easier because we already have all the information we need. We already found out that the slope of line BC is positive 2. So if the slope of line BC is positive 2 over 1, the slope of the dotted line that I just drew, which is perpendicular, is going to have a slope that is the opposite reciprocal, which would be, of course, negative 1/2. So our answer to finding the slope of the altitude from point A, that answer is going to be negative 1/2. I want you on your own to figure out the slope of the altitude from point B and point C. Question E asks us, is angle C a right angle? I will let you answer that on your own and explain why, give me a good explanation. I am drawing in line segment AC, and we want to know, is that angle a right angle? And only you can answer that based on your knowledge of slopes and opposite reciprocals. The next topic we're going to look at is going to be angle pairs formed, specifically when we have parallel lines or vice versa. So if we have parallel lines, what angle pairs are formed? Or if certain angle pairs are congruent, what parallel lines do we have? This was basically a topic we covered in Chapter 4 and really carried over a lot into Chapter 5. So I'm going to have you guys do some of these problems on your own. I'm going to go through a couple with you. You may want to pause the video here for a minute or two and really examine the diagram that I've given you, because there's a lot going on in that diagram. Now, question number 1. If angle 9 and angle 11 are congruent, what lines are parallel? Now, the one thing that I always like to do, I like to take those two angles and I really like to highlight the two lines that look as if they are parallel. This is not necessarily a guarantee, but these two red lines certainly look like they have the potential to be parallel. We just need evidence to prove it. And then the other thing that I like to draw in would be the transversal. In this case, line JK is our transversal. Now, when I have my lines outlined so clearly, I can now see a clearer picture of what 9 and 11 are. 9 and 11 will indeed make lines PJ and KN parallel. And the reason is because if corresponding angles congruent, then we have parallel lines. Question number 2, I'd like you to do on your own. If angles 16 and 17 are congruent, what lines are parallel and why? On your sheet of loose leaf, I would like you to redraw the two lines that you think are parallel, and I also want you to draw in a transversal with angles 16 and 17 also on your diagram on loose leaf. I want you to do the same thing with question number 3. If 18 and 19 are congruent angles, what lines are parallel? Do the same thing. I want you to draw a picture, put in your transversal, and then answer the question why. Your reasoning is going to be much like my reasoning. Your choices, of course, would be if corresponding angles congruent, if alt-int angles congruent, or if alt-x angles congruent, then we have parallel lines. Moving on to question 4, let's do 4 together. Now 4 is a little bit different because you can see, instead of giving you congruent angles, I am giving you supplementary angles. We had 2 theorems dealing with supplementary angles. So I have angle 4 and I have angle 7 given to me as supplements. It appears as though this blue line GE and this blue line HF will be parallel. So I'm going to write that down. GE may be parallel to FH. Again, I want to get my transversal drawn in. My transversal in this case, GH. And now this gives me a lot clearer picture of angle 4 and angle 7. And of course they are given to be supplements. So now I have a very clear picture, and it is true that GE and HF are parallel lines. And my reasoning, and most people miss this on the quiz and the test, they did not give me very good wording on this theorem. If, and this is the key word, interior, angles 4 and 7 are in between the blue lines, they are interior angles. So if interior angles on same side of transversal are supplementary, then we have parallel lines. We also had a theorem that said if exterior angles on same side of transversal supplementary, we have parallel lines. A lot of mistakes on that on the past test and quizzes. Questions 5 and 6 are pretty much the opposite of questions 1, 2, 3, and 4. This time I'm giving you parallel lines and asking you what angles are congruent. So we'll take a look at question number 5 together, and I'll let you do 6 on your own. So, going back to the two red lines, PJ and NK, if those two lines are parallel, what angles are congruent? Now, there may be more than one answer here. We've already established the fact that if those two red lines are parallel, 9 and 11 would be congruent angles because they're corresponding angles. But also, I'm going to put another answer down. Angle 10 is going to be congruent to angle 12. And the reason, if parallel lines, then corresponding angles congruent. You guys can go ahead and finish up question number 6. Got a little bit of a typo there. If PJ is parallel to line NK, what angles are supplementary? There's also a couple choices for you to answer there. Now, to end here, on this slide, you can see there's a ton of action going on. I've only asked you 6 questions, but really, I could have asked you a lot more. Another topic we covered in Chapter 4 was detour proofs. Remember, detour proofs are proofs in which we are going to prove one set of triangles congruent in order to prove a second pair of triangles are congruent. Now, this is a problem I took from an old test review. It's a pretty straightforward problem. I think you'll have a pretty easy time with it. And so what I would like you to do is I'd like you to do this problem on your sheet of loose leaf. I have everything marked out on the diagram. All I need you to do is give me the statements and reasons. And like I said, I think it's a really straightforward problem that I don't think you'll have a whole lot of issues with. One hint that I will give you, when you prove triangle ACH congruent to FDG, you're going to use CPCTC to tell me that AC is congruent to DF. And we notice in the given information, BC is congruent to DE. One step that a lot of guys miss is that segment AB is congruent to segment EF by subtraction. So make sure you throw that in your proof. To conclude Chapter 4, I'm going to mention a couple things. First off, we covered what we call the equidistance theorems. Those were the two theorems, 24 and 25, that I told you I would put on your test, and you could use them by saying Theorem 24 or Theorem 25. I will not have either of those on the final exam, so I won't test you over those two theorems. You may, however, run into Theorem 23. Not a guarantee, but you might. And Theorem 23 told us that angles that are supplementary and congruent are right angles. So, in a diagram, if I tell you that angle 1 is congruent to angle 2, we already know they are supplementary, so it guarantees us that angle 1 and angle 2 are right angles. Based on Theorem 23, angles that are supplementary and congruent are right angles. And that concludes Chapter 4.